So today now we're trying to write the equation of a quadratic, but now we have the vertex and an additional point. So yesterday and this morning we did x-intercepts and one additional point. Now we have the vertex. So the process is basically the same. You just have to use the vertex formula. So remember what that looks like. It's y equals a times x minus h squared plus k. And you might remember this from the absolute value stuff. HK is just that vertex. All right, so h comma k is your vertex. So that's pretty much our steps. We're going to plug in h and k, whatever the vertex is. I plug that in for h and k, and then they have to give me an additional point for the same reasons, right? Because if you think about it, can't you envision an infinite number of parabolas that have a given vertex? If I told all of you, draw me a parabola that has a vertex at 1, 1, I would get 20 different graphs, right? Because there's so many of them. So that's why I have to give you one additional point to narrow it down to the exact one that I'm talking about. Okay? So if we look at, I think A is too easy. Why don't we start with E? So E says we have a vertex at 2, 5. And then our other point is at 3, 7. Other point 3, 7. Okay, so now I don't need this anymore. There's all the info that I need. The only place where I notice that kids make a lot of mistakes is that they don't set the vertex as h and k. The vertex, there's your h, there's your k. The other point, that's your x, that's your y. Does that make sense? Vertex always has to go in as h and k. So if you know the formula, again, guys, you're just plugging in all those pieces. The only thing that you're not going to know is a. So again, we're going to solve for a and then just put it back in. Okay? So I'm first going to start off by just plugging in h and k into my formula. So y equals a times x, and then what would I write? Minus 2 squared, and then plus k plus 5. So there it is with h and k plugged into it. And now I'm going to plug in the x and the y. Again, if you want to, you can do this both in one step, but I like to separate them. So now y is 7. I don't know what a is, but x is 3. And now I have an equation, only one variable. I can go ahead and solve for a. So let's just do our math. 3 minus 2 is 1, and 1 squared is 1, so I really don't even need it anymore. And then plus 5. So in order to get a by itself, I just minus the 5. That's it. So in this case, a is 2. And just like last time, I'm just going to pop that right back in there. And that will be my final equation in vertex form. So that would be 2 times x minus 2 squared plus 5. So that's pretty much it. If I just say, give the equation in any form you want. If you have to convert this into standard form, how would you do that? If I say this has to now be in standard form, what are you going to do? Good guess. The problem is you would have to do the exponent first. So you have to square the x minus 2 first, and then you can multiply by the 2 and add the 5, right? Because I got to follow my order of operations. So it's really like doing this. If it helps you to write it this way, 2 times x minus 2 times another x minus 2, and then plus the 5, right? Because isn't that what x minus 2 squared is? So you're going to do the plus 5 at the very end, right? Because I have to do multiplication before I do addition. So you can kind of just ignore it for a minute, multiply these together, and then go ahead and add your 5. So I'll start off by foiling these two in the middle. X squared, you're going to get a minus 2x, and minus 2x is a minus 4x plus 4. Now I can distribute that 2. And now I just have to add the 8 and 5, and I'm done. Hey, that's not so bad. Okay, so again, this is your answer in standard form. If you are not asked to give the equation in standard form, don't bother. You could have left it. This is your equation in vertex form. Now, what I would like to do is try one of the ones at the bottom here that are the graphs. So let's just look at the very first graph. Is everybody okay with this? Yeah, you did all right? Okay, so let's look at the first graph, 4A here. This is the same thing, except they just gave it to you in a graph form. So, what would my vertex be based on the graph? Need another. Where's the vertex? Negative 1, 0, right? So there's my vertex. Vertex. Oops. Nope. Negative 1, 0. Okay? And now another point. They don't have another point highlighted, but isn't there another point that you know you can tell what it is from the graph? Yeah, this one right here, 0, negative 3. 0, negative 3. So if they don't come right out and you know, put a dot and give you the ordered pair, just look for another one that you know crosses at a nice spot. All right? So now, oh, and tell me something about A before we even do all our work. It's got to be negative. So the graph is nice because it gives you a hint. It's saying, hey, your A is definitely going to end up being negative. So now let's just take these two values, that's all I need, and I'll plug them into our formula. Remember, this is, let's see if I can squeeze in there with another color. This is H, this is K, this is X, this is Y. And you just pop them in the formula. So it's going to be X, what? Plus 1 squared, and then plus K. Since K is 0, what do? You don't even need to write it. Don't bother writing plus 0. I mean, you can, but why? Leave it. Save the ink. All right, and now I'm just going to plug in the other point. So Y is negative 3. I don't know what A is. X is 0 plus 1, which is just 1, right? So, looks like negative 3 equals 1 times A, so isn't A just negative 3? Yeah, so when you have some zeros in there, it's a little bit nicer for you because a lot of things cancel out. So now, if I had to give the equation of this quadratic in vertex form, I just take that negative 3 and I pop it right back in there. So that'd be Y equals negative 3, X plus 1 squared. So there's vertex form. Take a minute and change that into standard form for me. See what that would end up looking like. So if you're forced to give it in standard form, remember, you cannot distribute that negative 3 first because this is being squared, right? So please don't do negative 3x minus 3 and then square that. That will get you a wrong answer. But if you want to write it as this, that's fine with me, and then just multiply it out, because that's really what x plus 1 means. And make sure that you FOIL. X plus 1, the whole thing squared, is not x squared plus 1. That's another very common mistake, right? Because you can't just square each term. You have to do both of these times both of these. And that does not come out to be x squared plus 1. So, I'm going to FOIL those two together first. And you'll see it's not x squared plus 1. Look at what it is. X squared plus x plus 1. So it's really x squared plus 2x plus 1. And now just distribute that negative 3. Did you get what I got? You did? Is A what we were expecting? Yeah, it was negative, so that was definitely a good sign. We should have checked way back when we got A from the beginning, but I forgot. But yeah, A was negative. I knew it was supposed to be because my graph was down. So that looks pretty good to me.